Now next thing we're going to talk about the dangling pointer. So let's create another program 65 dangling pointer. So here we're going to talk about the dangling pointer. Before that, let's create the template, then I'll talk about it. So hash include stdio dot h and int main function, and the main function we're going to write that the last return 0. All right, so this is the basic template of a C program. So now what is dangling pointer? That we already talked about. A dangling pointer is a C in C is a pointer that points to the memory location that has been freed or deallocated, or a pointer that points to the variable that gone out of scope. So a dangling pointer occurs when a program tries to access memory that has already been freed or deallocated, leading to undefined behavior. So this can result in errors or unexpected behaviors such as segmentation fault, program crashes, and data corruption. So we're going to see how we're going to deallocate memory, and after that we're trying to access. So we're going to talk about this dynamic memory allocation. If you don't understand right now, we'll understand in the dynamic memory allocation better way. So how we can allocate memory dynamically. So here we'll declare a pointer, star pointer, that is going to be integer, and here we're going to typecast it to integer and star. What I'm telling, if you don't understand, completely fine, we're going to learn the next topic. And here is one keyword, malloc. So this is for the allocation of memory dynamically one way. So malloc we write, and if we write size of int, so this is allocating memory dynamically. So this is allocating memory for an integer dynamically. This is how we allocate. Now if we want to give the ptr as some value, let's give some value 78, and this is what assigning value to the memory location pointed by the ptr variable. So this is how dynamically we allocate, all right, by using malloc keyword. So if you can hear 2-3 words, that malloc, calloc, realloc, and free. So those are the 3 terms we use for dynamic memory allocation. So normally how we do it, declare variable, we write int a equals to 10 directly. So that is what static allocation, but this is what dynamic allocation. All right, now this is we memory I created. Now we're going to free it. Free it means what? Delete it. So delete what? PTR. Free is a keyword, so that is for deletion, basically deallocating the memory. So dynamic, this is what dynamic memory allocation. This is memory allocation. This is memory allocation dynamically, and memory deallocation. All right, now we know that dangling pointer happens when we free the memory, we delete this memory, after that we want to access it again. So what is that? Printf, if I write here and I want to access that %d and I want to access that ptr, because we already deleted but still we want to access that ptr value in it, right? So accessing the memory pointed by the pointer, that is what? Dangling pointer. So this is how we're going to access, and I'll hit Ctrl S and I'll clear it out first and try to run the code. So when I run the code, you can see it's saying that dangling pointer. So you already deleted it and you are trying to access, right? So in this program, what you can see, a pointer to integer pointer variable is declared and memory of an integer is allocated using malloc keyword, and the value is to be 78 is assigned to the memory location to the pointer ptr. Then the memory is deallocated using free keyword, leaving ptr as a dangling pointer, because we already deleted this memory from the RAM, right? Finally, the programs try to access the memory pointed to ptr using star operator star ptr, which leads to undefined behavior because our memory has been already avoided. So to avoid creating dangling pointers in C, it is important to always free memory only after it's no longer needed, to avoid accessing memory through pointers that has been deallocated and gone out of the scope. So that is what, that time it will not create dangling pointers. So we're going to learn what is this malloc, calloc, reloc keyword and free also, but this is allocating memory dynamically. If you remember, we used to allocate memory statically also in k equals to 90. This is what static memory allocation. So here this happens in stack, that's why this, whatever the static memory allocation happens, that is happen in stack. So allocation deallocation takes place automatically, but when we create dynamically, when we create in the line 4 number line, this is dynamic memory allocation for integer variable. So that time you that is allocated in the heap, in the memory structure, right? So that is been allocated by us, so we have to delete that memory from our side also. That's why you use the keyword free also. So this is all about dangling pointers. Now we're going to see the each and everything about the dynamic memory allocation. This malloc, keyword, calloc, reloc and free. These things we're going to see. Now next topic we're going to see is dynamic memory allocation. I'll clear it out first here. So here we're going to talk about dynamic memory allocation. So it's a procedure of allocating or deallocating the memory in the runtime. So basically till now we declaring variables array, that was all was those were static memory allocation. It means you cannot change the size of that array or variable whatever in a runtime. So that is what static memory allocation. Now we're going to study about dynamic memory allocation in details. So here in C language there are 3 ways to allocate memory dynamically. So what are those 3 functions? Malloc, calloc and reloc. So to use dynamic memory allocation will include 3 predefined declarations, that malloc.h, studio.h and everything that is going to be we're going to write in the header file. So first thing we're going to see is the malloc function in C. So by using this predefined function we can create the memory dynamically at initial stage. So malloc function requires one argument of type size type, so that is the data type size, and that's create memory in byte format, and initial value is garbage. So how we're going to declare it and everything we're going to see one by one. So let's create one more file and name it as 66, and we're going to name it as malloc.c. all right, now we're going to write the header file here, hash include stdio.h. we're going to include one more header file, that is going to be hash include std library.h. So these are the 2 library header file we have to include. Now we're going to write the main function. So after writing the main function, at the last I'll write the return 0. all right, so I've written it wrong spelling, it's going to be integer. All right, now here we're going to declare a pointer variable star ptr. all right, I declared a pointer variable, and let's declare one variable n, and that is the we're going to take, and let's give the initialization value to 5. all right, now we're going to use printf in this statement what you're going to write is enter the number of elements, and that is going to be what, percentage d, and we go to the next line, and that is going to be stored in which variable, that is going to be n. All right, so this is, we have taken it. Now in the ptr we're going to store the everything. Either you write the ptr int ptr here, declare, or directly in star ptr, you can do that also, that is completely fine. Now here the malloc is going to return void type, so we're going to typecast it to integer. So int star, this is what we typecasted, and malloc is the keyword. And how many numbers, when I was telling that it has syntax, what is the size type? So size type is what, what is the size we have taken? 5. So 5 multiplied by size of what? Int. So this is the basic syntax of malloc. So what we have to take, this is what typecasting, because this malloc function till here it will going to give void type, so we have to typecast it to integer, because we are storing address of integer in pointer variable. All right, now if you see 5 into, I have written star, 5 star, so that is what, 5 is the type size. So what is the type is integer, size is what, type size is what, 5, then size of int we have to write this way. All right, this is what dynamic memory allocation of integer. All right, now what I have to write is, I'll write if condition. We're going to check if the memory is allocated or not. So we're going to write if else statement. So if it is allocated, we're going to say allocated. If it is not allocated, we're going to say it is not allocated. So in the if statement, what are you going to write? ptr equals to, if it is equals to null, if ptr is equals to null, we're going to print f, and we're going to say that memory not allocated, and we're going to use one function exit, and we're going to come out of it. So this is a function that is going to exit it. All right, now in the else part, what we're going to write is, we're going to write the printf statement. In this we're going to say memory successfully, spelling is wrong, memory successfully allocated using malloc. We're going to come into the then next line. All right, now this is what allocated memory. So what I have to write here, we'll write the for loop, and inside that for loop int I equals to 0, I is going to be less than n, and I plus plus. So till this time we'll be storing ptr I, and that is going to be incremented by 1 every time. So I plus 1. So it is going to be printed, and that is going to be stored in the ptr array. All right, now next what you're going to write is, we're going to say the elements are that. So what I'm going to do is, I'm going to copy this whole thing, Control C, and I want to paste it here. So here what I'll say is, instead of writing this comment, I'll say the elements of the array are. So elements of the array we're going to print, we're going to start from I equals to 0, I less than I, and I plus plus, and in the print here we're going to write printf, and inside this what we're going to write is %d, comma, I'm going to space, give space, and here I'll write ptr and with the index, that is I, right? So this is going to print, and at the last I have to use semicolon. I'll hit Control S. This is dynamic memory allocation using Malloc keyword, and this is going to be done. I'll hit Control, right click here. So if you see, the values are 1, 2, 3, 4, 5. It is getting printed because I equals to 0, that is 1, then 2, 3, 4, 5, it is getting printed that way. So this is what dynamic memory allocation using Malloc, right? Now if you want to if you want to delete deallocation, you want to do deallocation. So how to do deallocation? So coming out of everything, I'll write here free, and you're going to write what is the dynamic allocation we did for the PTR, right? So we'll write PTR, and here this will deallocate it. I'll hit Control S, right click here, run the code, and it is done. So you cannot see any changes because it is done internally. It means it is deallocating the memory. And one thing we can do at the last, that so that it doesn't randomly choose any pointer variable is there, right? PTR, so it should not point to any other addresses, so we can assign it to null. This is a good practice, by the way. So if I hit Control S, I'll right click here, you will not see any changes, but that will be done. So this is how it is, the Malloc keyword we can do. Now same thing we could do with the Calloc, also Calloc function. So by using this predefined Calloc function, we can create the memory dynamically at the initial stage using the Calloc keyword. Requires two argument type. What is the count and size type? The count will provide a number of elements, and size type is the data type size. So when we are working with Calloc function, it creates the memory in the block. So here we have given size type to be 4. Okay, let's jump to the next in the Calloc, right? So for that, what we'll do is we'll create one more file and name it as 67, and we'll name it as calloc.c. all right, so here we're going to write the header file again, hash include stdio.h. now next thing we're going to same thing, include that header file, hash include stdlib.h. okay, now I'm going to write the main function int main, and by writing this main function, so these three are Malloc, Calloc, Realloc. These three are allocations for memory dynamically, and free is the keyword for deletion, right? If you learn in C, so C++, so you could see new keyword. So new keyword is used for dynamic memory allocation in C++, and delete keyword is used in C++ for deletion. Similarly, this Malloc, Calloc, Realloc, three things are there to allocate here. So I'll declare one pointer variable in star ptr, and this is what I declared, a pointer variable. Now what I'll do is same thing we're going to do, int, we're going to take variable n and we'll give it to size 5, and here we'll write the printf, and in this printf statement what we're going to write is enter the number of elements, and those elements is going to be what? Integers. So we're going to go to the next line, and that variable we're taking, that is n, right? We have given n equals to 5 already. Okay, so now we're going to declare that pointer variable with the Calloc keyword. So we're going to typecast it because we already know that it is going to return void type, so that's why we're going to typecast it. So we typecast it to integer, and we're going to write the Calloc keyword. And after writing the Calloc keyword, we have to give two things, two parameters here that I already talked about. So what is the first parameter? That is going to be the count. What is the count? Count is going to be 5, and next parameter is going to be the size type. So first thing we're going to div count, that is count is what, n, and size type is what, here, integer. So size type we're going to write is size of, and that is we're going to write is integer. Alright, so this is how it is, this calloc keyword is defined. Alright, again we're going to write the same thing if else statement. So in if, we're going to write what, that if ptr is equals to null, if ptr is equals to null, then we're going to say, that we're going to write printf statement, and in this printf statement we're going to say memory is not allocated, right? And we're going to go to the next line. All right, so this is done, and we're going to use the exit function to exit the function here, if statement here. All right, now we're going to come to the next, that is else statement, and in this what are you going to write, the two for loops that we written previously also. So what I can do is I can come here and I can just copy from here. So if I copy from here till here, Control C, I'll go to here and I'll paste it. What I have to do is I have to take this free and everything to the out of this else. Control X, Control V, and it should not be else, and this is all. We did something wrong, so that's why it's showing this red bracket. We'll try to solve it. What is that? What is the scope of this? I have to remove this one. Now it's looking good. So here we're going to say is by Calloc, and this is going to be all going to be same. So this at the last, it's going to free. I'll click it here, I'll clear it out first, and I hit here Control S, then I'll right click and run the code. So after running the code, you can see 1 2 3 4 5 it is printing. This is what memory allocation using Calloc, and free we already used. Now same thing is going to be again Realloc. So using Realloc, you're going to this is also predefined function. We can create memory dynamically at the middle stage of the program. Generally this function is required to use when we are reallocating memory. So this Realloc keyword is used. So this Realloc keyword requires two arguments. That is, one type is what is the size type, and void we're going to use that indicates previous block base address, that is size type in the data type. So we're going to use that thing. So same thing we're going to write it again for this reallocation, right? That. So for that we're going to use the help of Calloc. So then we're going to reallocate that memory, and we're going to free at the last, and we're going to give it the name to we're going to point it to the null. So what are you going to do? Let's create one more file and let's name it as 68 and Realloc. So this is what reallocation of the memory, right? So what we'll do is when we write Realloc, here we have to include two different header files. So what we'll do, hash include studio.h, and here we're going to write hash include cunio.h. So this is one header file, and another header file is going to be malloc.h. So these are the header files for the whatever the files we're going to use. Alright, int main function we're going to write, and in this main function at the last we're going to write return 0. I'll come above, and here we're going to declare one pointer variable. Let's name it as ARR this time. Alright, now I want to declare two variable that is going to be int, let's say s1 comma s2. These are the two variables we have used. Now what I'm going to write is I want to write printf, and in this printf I'm going to go to the next line, and after going to the next line I'm going to say enter array size 1. So we're going to enter the size of the array for the array 1. Now here we're going to use scanf for entering the values, and here we're going to write percentage d for the integers, not capital D, percentage d, and that is stored in where s1 variable we already take, right? S1, that is going to be address of s1. All right, now same thing we're going to do. First thing we're going to do is allocation for this, right, using the Calloc. So using Calloc, how to do allocation memory? So we'll write array, we'll typecast it to integer because Calloc returns void, so we typecast it to integer, and I will write Calloc keyword, and after writing Calloc keyword we'll give the what is the size type, right? We have written the s1, so s1 we have written, and size of this is the size type is going to be integer, and this is how it is defined. We already created the memory dynamically. Now we're going to use printf statement, and in that printf statement we're going to go to the next line. Before that I have to give this next line, and we'll say enter the values, right, and I'll come out of it and give s1 that is stored in s1. Now I'll write a for loop, and I'll write int I equals to 0, and I is going to be less than s1 I plus plus. This is going to write in the for loop. So here we're going to take the input from the user, right? So for that what we'll do is we'll write the scanf here, scanf, and inside the scanf what I'm going to write is percentage d, it's an integer, and we're going to store it in address. We're going to write address of in array, we're going to store, so array of I. All right, so this much is done. Now we'll come out of this for loop, and what we'll say is we're going to do for the array size, that is the array for size 2. So same thing we're going to do, that is we're going to reallocate the memory for this now. So for that everything is going to be same, only one thing we're going to have to do is we'll just do copy, and we'll do some changes. All right, I'll copy it here, and I'll come and paste it here. So here what we'll say, enter the size, enter array size 2, we're going to say, all right, percentage d, and s2 we're going to take scanf for the s2, and we're going to here declare it by Realloc, not Calloc. We are doing reallocation. So what I'll write array, and when we do Realloc, so again typecast it to integer int star because it returns void type. And how it is done, we're going to use Realloc keyword, Realloc keyword reallocation, and what is that? We are passing array and size type, size of int, and what do you want to do? We want to add s1 s1 plus s2. All right, so this is what going to be is this is going to reallocate the memory. So here we're going to change it to s2, and here I is going to be not 0, here it is going to be starting from s1, right? I equals to s1 and I is less than s1 plus s2, because from there we are, from s1 we are trying to reallocate the memory. All right, Now it's going to be printed in array of address of array of I. Alright, now to print the address in the what is there in the array data list, right? So what I have to use is printf, and inside this printf what we're going to write is we're going to next line, and here we're going to say array data list and we're going to write a for loop, and inside this for loop what we're going to write int I equals to 0, and here I is going to be less than s1 plus s2. So this is still there, we have to print it, right? I plus plus. So here what you're going to write is printf %d and array of I. So this is all done. Now at the last, what are you going to do? We're going to write printf, and in this we're going to print the %d, we're going to print the array. So arr of I. Alright, now we're going to write the free keyword for deallocating the memory, that is a memory were allocated in arr. We deallocated the memory, and arr will be pointing to null so that it doesn't randomly choose any location and point and give garbage value. So I hit Ctrl S. Anything wrong we did, because it's showing error here, we have to find it out where is the error. So what we'll do is we'll not write this because we already done that, so we'll remove this line. So if we remove this, now if I come out of it, I'll hit Ctrl S, I'll click here and clear it out. So one more thing we'll do is we'll give some space here so that it doesn't come to consecutively. So I'll right click, run the code, and it is going to ask the size of the first array. So let's give size of the array to be 5, and let's give value as to be 10, 20, 30, 40 and 50. These are the 5 values I'm giving. Now it is asking for the enter the array size 4 in size 2, right? So we're going to give the size to be 4, let's say, and we'll enter the 4 values, let's say 11, 22, 33 and 44. These are the values we have given. Now if I hit enter, you can see array list is 10, 20, 30, 40, 50, 10, 11, 22, 23, 24, 22, 20, 33, 44. So here what you can see is it is reallocated, and from there it is getting done, right? This is how it is done. So it is all about arrays and pointers. We are end with dynamic memory allocation, we are done with pointers and everything. Now next topic is going to start is structure, union, enum. We're going to learn about those data types. So that is, those are the user defined data types. We're going to learn about those things in details.